What if ChatGPT could actually save you hours in Abaqus? In this video, I'm going to show you 5 powerful ChatGPT prompts that can help you debug errors, review subroutines, check your mesh, improve post-processing, and even validate your input file. These aren't generic prompts, these are prompts that I personally use for real Abaqus simulation. Let's get started. Okay, this is the first prompt. I said, I'm simulating microindentation with axisymmetric analytical rigid. So basically, here you need to write your project. So what's the project is about? Maybe it's additive manufacturing. Maybe it is cyclic loading. Then you have to mention the solver. I'm using a static general solver, and I'm attaching my abaqus.imp file. In the previous video, we talked about the imp file because it is a text-based file. It's better to use that for ChatGPT for fully comprehension. Then you need to upload your imp file. I'll show you later how to do that. Then you have to state that, review it carefully, and check for unit inconsistencies, wrong or missing material properties, incorrect element types, over or under constrained boundary conditions, contact definition problems, step setting that may cause convergence issues. List top issues you find and explain exactly how to fix each one. Let's go to the Abaqus. This is the model I have, and here is the detail of the step. This is the static general. You might have other steps. You have to mention that carefully, then go to the job. And here you need to create one job. So I want to name that ChatGPT job, then continue. And if you click on OK, you would see that here is our job, and you need to click on write input, and it writes the input in the file directory. This is the imp job, ChatGPT job. So you can simply click on it and hold, then drag and drop it here. As you see, it is here. Or if you don't have ChatGPT Premium, you can right click on it and click on edit in Notepad. And as you see here, we have the job here. And if you scroll all the way down, you see here is what we have. Control A to select all, then copy it here and click on paste. You can paste it here simply, then click on this one and wait for it. It's thinking to give you a better answer, checking the file and size, everything else. Wait for it a couple of minutes and it replies back with a good answer. And as you see, it took almost 2.5 minutes to give me a full detailed feedback about my job. So here we have some over constraint, overall is good, and it gives you how to fix prompt. So you can basically copy this one and you can open your imp file. You can simply replace it here with copy and paste, and it's a very long list. Second prompt is for the people who use Subroutine. This is the prompt. I'm simulating wire arc additive manufacturing, or here you can write your own project using deflogs. Here is my Abaqus subroutine. Check for compilation errors, wrong variable dimensions, unit inconsistencies, logic errors affecting stability, explain what the code is doing, and give a correct version if needed. Then again, here is the subroutine code. You can open it using the compiler, or you can use the notepad, or you can drag and drop. So I use the drag and drop and enter. This one also takes a while, so be patient. By the way, if you enjoyed this video so far, please share your feedback with me in the comments down below. It's totally free for you, but it helps me a lot to grow and make more videos like this. Thank you. This time it didn't take much time, only 30 seconds. Here we have full feedback about our code, and here we have the issues found, major logic stability bug, and many more here. And in the end, it gives a corrected, safer version. Here we can copy and paste it to have a better result. Next prompt is very handy. So here is the Abaqus error message from .dat or /.msg file. Explain what this error really means, the most likely causes, step by step how to fix it. Assume I'm using explicit or standard. For instance, here we have the standard and nonlinear material behavior. This is my IMP file just in case. So let's go here. This is the ChatGPT job, which is the IMP, drag and drop, and this is the job. Error is 2-minute attempt made for this increment. By the way, there's a full detailed video on this topic. Don't forget to check it out. I put the link on top right here. Here is the .dat file. Again, drag and drop, or you can right click on it, edit in Notepad, and here is what we have. Or here is the MSG file. Let's open it in here. This is what we have. Let's drag and drop it here. Or if you don't want to do that, go to the monitor here, simply copy and paste it here, like error, and press enter. Same as the previous one, it took 2 minutes. And here what this error means, these are the causes, and this is the node from the .msg file. Most likely causes, and as you see, this is super accurate. U2 is equal to -2. I deliberately put this error to see how accurate is ChatGPT, and here is what we have. The -2 is not correct, and if you have watched the video, it was 0.009, and then it shows how accurate is ChatGPT. And here we have more comments about this, but the first one was the most accurate one. Here is what we have, full detailed feedback. The next prompt uses the image. I'm uploading a screenshot of my Abaqus mesh, analyze it and tell me if refinement is placed correctly, if element quality looks problematic, if transitions are too aggressive, what I should change, partitioning, element type, and size, be specific. So let's go to the Abaqus. Here is the mesh. Let's hold Shift, Windows, and S. And select this one, go to ChatGPT and enter it here, press enter, and it gives me the feedback instantly, and it says it's high quality simulation FEAMASTER. Thank you very much. I'm really flattered by this, and it gives me the refinement. We have the issue. The refinement is only based on distance, not the physics, blah blah. Recommendation: if your physics is sharp, add localization refinement, zone partition, and stuff like that. It gives me other things here, and it gives me the concern. Near the left edge, element become very thin vertically, high aspect ratio, and in the video I explained that why I chose these element types. And if you go to the Abaqus once more, and this time I'm uploading a very bad mesh here. Let's see what it says. Press enter. And it says this is the completely different story. And it says we have many distorted quads, and why this is bad: poor stress accuracy, artificial stiffness, and convergence issue if we have plasticity and contact, which we have. And as you see, this is a very accurate feedback. Final verdict: the mesh is not simulation safe for contact or nonlinear analysis. It might run, but result is questionable. Last but not least, this is for the post-processing. I want to extract clean force versus displacement and stress strain curves from Abaqus simulation tensile test. Tell me which output variables to use. from which region, node RP integration point, common mistakes to avoid, how to make graph publication quality, and in the end I can give ChatGPT my results and it makes me a better graph. So let's go to the Abaqus. Now I open this tensile test dactyl damage. Here is what we have. I can send the image to ChatGPT. Just simply taking a screenshot. I want to get rid of this first. So here it says which output variables to use. We need RF or RF2 in the Y direction, and we need to have U2. So let's go here in Abaqus, and from XY data, ODB field output, continue, and here in the unique nodal, we can have RF2, and in the U we can have U2, and from which region to extract, it says extracted from the reference point. So here in the selection, we can edit selection, or we can have the node set. We have assembly constraint, reference point. Then if we plot it, here is what we have. Then to give the data to ChatGPT, we can go to the operate on XY data and continue. From combine, we can have U2, RF2, and plot expression. Here is the force versus displacement. If you go to the XY data and temp, we can click on edit, select the first one, hold shift, go all the way to the end and Control C and paste it here. Say this is the force displacement data, please draw a good publication quality graph for me. Again, it starts analyzing the data. There we go. This is the graph here we have. We can have some refinements. You can download the figure from here. I want you to remove the grid for me and get rid of the blue Excel color. So it didn't pay attention to the color scheme we explained for it, but all in all it is good. It got rid of the grid so that we can download the plot. That's it. I hope you enjoyed this video. Please smash the like button if you did. And if you want to build a ChatGPT based model from scratch without doing anything, click on the video on screen before it ends, and I see you there. Stay tuned.